Welcome to Physics and Rapid YouTube channel. In today's video, I'm going to continue solving previous year question papers on the topic Bohr model of hydrogen atom. Yes, let us start with the first question. The first question we have here, a positronium atom consists of a positron and an electron revolving around same center of mass point. Compare its ionization energy and spectra with hydrogen atom. This is a question. Now, what they have given in the question to find the binding energy, right? That is the ionization energy, they have said. Ionization energy, not the binding energy. Ionization energy. To find the ionization energy, we must know the energy of the hydrogen atom, right? What is the energy of the hydrogen atom? That is 13.6 Z square electron volt divided by N square. So N is the spectral number, that is a number of energy levels. N can take the value 1, 2, 3 like that. And what is Z square? Z square is the atomic number, right? Now concentrate. We have here positronium atom. So positronium atom means we have a positron and the electron, right? In a positronium atom, we have a positron and electron. So both are having the masses same, that is mass of the electron and mass of positron is one and the same, right? So that I have already told in the previous class itself, the mass of the electron and the mass of the positron is one and the same, but the charges are different. It is having a positive charge and it is having the negative charge. Now we need to find this energy. So we want to find this energy means this formula is not sufficient. We need to write the complete formula, that is energy En, which is equal to minus this constant term. We need to write in terms of the constants, that is m z square e to the power of 4 divided by 8 pi epsilon naught square n square h cut square. Now we need to observe for the energy term, mass is directly proportional. Here we are considering the infinite mass and we are writing the final answer for the hydrogen atom. Now we have a positronium atom. Positronium atom means reduced in mass come into the picture. That reduced in mass is defined as m, which is equal to, here we have a mass of an electron and the mass of a positron. Combination of positronium is positron and the electron. So it is a mass of an electron and mass of a positron divided by mass of electron plus mass of positron. So this is the reduced mass formula. You can write instead of m to be mu. So solving for mu, we have a, instead of mass of proton, we can write it as mass of electron divided by mass of electron plus mass of electron. So mu will be me square divided by 2 times of me square, and one of the me get cancels, it will be me divided by 2. So I'm substituting the value of m to be mv divided by 2. So we are getting the energy value En, which is equal to minus me divided by 2 z square e to the power of 4 divided 2 into 8 times of pi epsilon naught square n square h cut square. Right. Now what we have here, we have me z square e to the power of 4 8 pi epsilon naught square and h square can be written as, for hydrogen like atom, can be written as to be equal to minus 13.6, right, electron volt divided by n square. Here one more term is added, that is half divided by 2. Okay, now compare its ionization energy and the spectra with hydrogen atom, they are saying. So I'm comparing the ionization energy. So energy this much, ionization energy will be positive. So hydrogen atom is having the energy that is equal to minus 13.6 divided by n square electron volt, keeping the Z to be equal to 1. Here the energy becomes half. That is, instead of negative, the ionization energy will be positive, as I have told in the last class. That is E infinite minus En. So that is equal to minus 13.6 electron volt divided by 2 times of n square. So this is the energy we are getting for the positronium, and this is the energy for hydrogen atom. On comparing, it will be reduced by half, you can tell. Now what will be the spectra with hydrogen atom? The spectra is nothing but the wavelength. Yes, we will see now. What is the wavelength formula for the hydrogen atom? That is a wave number I have told. It is 1 divided by lambda, which is equal to r infinity 1 divided by n initial square minus n final square. These are the energy levels. It can take the value to be 1, the value to be 2. It depends on the series. That is Lyman series, Balmer series, Paschen series, bracket series and Fund series. Okay. So now this is for the hydrogen atom. Now we will see for the positronium atom. For the positronium atom, here we need to see how the R infinite dependence. This is the Rydberg constant. So Rydberg constant, you can see it depends on mass. Okay. So it is directly proportional to the mass. If it is directly proportional to the mass, this is for the infinite case, as I said. This is for the infinite case. The value we will get around 1.097 into 10 to the power of 7 is the value for this Rydberg constant. Now it is a positive. This is for the hydrogen atom. The equation 1 I am writing. Now for the positronium atom, instead of m, it will be reduced mass. R infinite is directly proportional to mu. So we need to substitute the value for mu. So what we got, mu, which is equal to mass of electron divided by 2, right? From the previous slide, you can cross check. So R infinite, how can I write? It is directly proportional to Me divided by 2 for what this is positronium. So simply you can write R positronium is directly proportional to R infinite divided by 2, because R infinite is mass. So mass divided by 2. I hope this point is clear to you people. Now substituting the value of Rp in this, so it will be 1 divided by, I'm going to write again, 1 divided by lambda p. Lambda p is for positronium, which is equal to, instead of R infinite, it will be Rp 1 divided by n initial square minus 1 divided by n final square. Okay. Now instead of Rp, I am taking as R infinite divided by 2 into 1 divided by n initial square minus 1 divided by n final square. Yes, I hope everyone is clear, right? Now we will divide this equation 1 and 2. Now dividing equation 1 and 2, what we are getting? 1 divided by lambda h whole divided by 1 divided by lambda p, which is equal to R infinite divided by R infinite divided by 2 into 1 divided by ni square minus 1 divided by n final square divided by 1 divided by ni square minus 1 divided by n final square. I is the initial and f is the final. So these get cancels and the r infinite get cancels. Now on rearranging, we will get 1 divided by lambda h. If I take to the above, it will be lambda p. Now here if it goes above, it will be 2. So lambda p, which will be equal to 2 times of lambda h, is the right answer, as you can see here. Okay. Now let us proceed to the next question. What we have in the next question? For example, if in this question only, if they ask, see, we have in this question compare its ionization energy and the spectra with the hydrogen atom. In the same question, if they extend the question and ask what will be the value for the radius of the hydrogen atom and the velocity of the hydrogen atom, for that answer will be For velocity of the hydrogen atom, it does not depends on the mass. The velocity it is independent, independent on mass. So velocity of the positronium and the velocity of the hydrogen atom will be one and the same, independent of mass. Okay. Now what about this radius? So radius value is Rn is directly proportional to uh, R naught into n square, and it is inversely proportional to the mass. Okay. So as it is inversely proportional to the mass, you can see applying this formula you will get. Now this is for the hydrogen atom. Now the positronium atom will be, what will be the positronium atom? So positronium atom, instead of this m, it will be mu. So if it is mu means I am writing here positronium atom is directly proportional to R naught 2 times of n square divided by mass of electron. Am I right? Instead of m, it will be mu. So mu value which is equal to ma divided by 2. So 2 will go above. So r naught n square divided by ma, how can I write? Can I write Rn, that is the radius of the hydrogen atom, Rn, or the r simply the r for the hydrogen atom? So after removing the proportionality constant, if I think to be equal to equal and some constant, it will arise. So Rp which is equal to 2 times of radius of the hydrogen atom. Yes, I hope everyone is clear with this question. We will move to the next question. Yes, what we have in this question, let us solve this question. How much energy is required to remove an electron from hydrogen atom in its ground state and n which is equal to 8 state? Yes, and calculate the corresponding energy for singly ionized helium. Okay, yes, let us solve this. Now, what they have given in the question, energy required to remove an electron from hydrogen atom, this is what they have given. Now, what is the energy for an hydrogen atom? You know that the energy for the hydrogen atom for the nth state to be equal to minus 13.6 electron volt divided by n square, right? And they have given the value to be for the ground state and n which is equal to 8 state. What is the energy required to remove an electron? So first we will see for n which is equal to ground state or n which is equal to 1. So energy En which will be equal to minus 13.6 electron volt, in place of n it will be 1. So the value will be minus 13.6 is the energy of the hydrogen atom. But to remove an electron from an hydrogen atom, we need this much of positive energy, that is 13.6 electron volt. I hope this question is understood by all. Now again come n which is equal to 8 state. So n which is equal to 8 state means 8 which is equal to minus 13.6 electron volt divided by 8 square is 8 8 is 64. So this much of positive energy is required to remove an electron from the hydrogen atom. Okay, getting my point? Now the question continues, calculate the corresponding energy for single ionized helium. Now single ionized helium also follows the Bohr model of hydrogen atom. Actually Bohr model, it is valid for hydrogen atom, singly ionized helium, lithium, beryllium, like that. It should be singly ionized atom. Okay, now this is He plus. What is the Z value, that is the atomic number for helium, to be 2? How the energy depends on Z, that we need to concentrate. So En which is equal to what? Minus 13.6 Z square divided by N square into electron volt, right? So here only the term added is, that is the atomic number, that is Z which is equal to 2. If Z which is equal to 2 for the ground state of a singly ionized helium atom means minus 13.6, instead of Z square it will be 2 square divided by N square. N square value is what? Again the 1 square electron volt. So this much positive energy will be required to remove an electron from the singly ionized helium atom. I hope you people are getting my point. So it will be positive 13.6 into 4 times of electron volt. Now the same carries for n, which is equal to 8. So energy E8 will be equal to, so E8 will be equal to, what is the solution? Minus 13.6 into Z square divided by N square electron volt, right? So here it will be positive 13.6. What is Z square? 2 square will be 4 divided by N. N is what? 64. 8 into 8. The N value, which is equal to 8, they have given. Now 4 ones are 4 16s are, this much of positive energy is required. Okay, so I hope it is clear with this question. Let us move to the next question, and very important question. A muon or the meson charge, it is having minus E and it is having a mass they have given, can be captured by a protons to form a hydrogen like basic atom. Calculate the radius of first line in Lyman series. For such atom, first line in Lyman series means N1, which is equal to 1, and N2, which is equal to 2, as I said in the previous video. Okay, now again, uh, calculate the radius of first line in Lyman series for such an atom. They are saying, right? Yes. Now can be captured by a protons to form a hydrogen like mesic atom. Now you need to calculate the reduced mass for this, right? What is the reduced mass? Before going to the question, what is the reduced mass? The reduced mass is nothing but mu. Mu here, protons and mesons are present. So mass of a meson, under meson we have a muon. Okay, mass of a muon into mass of a proton divided by mass of muon plus, it will be, wait a second, mass of muon plus mass of muon plus mass of proton. Okay, now mass of muon value is they have given in terms of mass of electron. So we will substitute that value. It is 207 mass of electron into mass of a proton. We know 1836 into mass of an electron. Okay, divided by 207 into mass of electron plus 1836 into mass of electron. Now on solving this, we will get the solution to be 186 times of mass of electron, somewhat nearly equal to this value. Now they have given the radius. Okay, so what is the radius value, which is equal to, I think there is something wrong in the question. I will cross check and I will continue with. Yes, the question is wrong here. It should be the radius and binding energy. We need to find the radius, binding energy, and wavelength. Okay, wavelength. I'm going to read the question. Wavelength of first line of hydrogen. First line in Lyman series for hydrogen atom. Okay, so hydrogen like atom. Here they have given it as mesic atom. Okay, again I'm going to read question, just confirm. A meson, it is a muon comes under a meson charge which is having minus E and mass 207. Mass of an electron can be captured by a protons to form a hydrogen like mesic atom. Calculate the radius, binding energy and wavelength of first line in Lyman series for such an atom. Okay, so this is the question. Now for everything this was required, that's what I was thinking, something was missing in the question. So this is the radius. The radius part, what we have, how it depends on the mass is, first we will take the radius part. So r is equal to r naught into n square divided by mass. So instead of mass it will be, this is, we will consider this is the radius of the hydrogen atom. Now for the mesic atom we will write in terms of small m here. So mesic atom, which is equal to r naught n square, instead of m it will be mu value. Now what is the value of mu? It is 186 times of mass of electron. So mass of electron instead of r naught n square divided by me, you can take the value for rh divided by 186. Okay, so this is the radius. You can substitute the value of rh for substituting the value of r naught. So r naught value, which is equal to 0.53 angstrom. Okay, and n value they have given for the, let us consider for the ground state only. So the n value will be equal to the 1 and divided by what is the mass? The mass of the electron. After substituting this only, you will get the R naught value. So R naught value includes this M value. For your reference, I am writing here. Okay. So this R naught value is completely 0.53 including this M. So to showing the difference, I am writing here M. Understood? So it is RH divided by 186. The RH value is 0.53 angstrom. Okay, after calculating, you will get the final answer in terms of meter. Okay, now we will go for the binding energy. Now, what is the binding energy? We will see the energy. Again, we need to calculate, that is En, which is equal to minus 13.6 electron volt divided by n square, or En, which is equal to minus m z square e to the power of 4 divided by 8 times of pi epsilon naught square n square h cut square, right? This is for the hydrogen atom. Now we have a mesic atom. So for mesic atom, instead of m, we need to write the reduced mass. That reduced mass we are getting minus 186 mass of an electron z square e to the power of 4 divided by 8 pi epsilon naught square h cut square. This n square I'm writing here. So this completely can be written as minus minus I have already taken to be 13.6 electron volt. You can solve this keeping the values of n. For the ground state, the value will be 1. Okay, if we consider to be a ground state, the value will be 1. Okay, now what they have asked in the question, one more question is added: the wavelength of first line in Lyman series for such an atom. So the wavelength means 1 divided by lambda. If you find, you will get the wavelength. Let me continue from here. So 1 divided by lambda, which is equal to r infinity, 1 divided by initial square, the Lyman series, it will be 1 square, minus 1 divided by 2 square, it will be 4. Right, this is for the hydrogen atom. So 1 divided by lambda h, which is equal to r infinite into uh, after solving, it will be 3 by 4. You can solve, right? Yes. Now we want for the mesic atom, 1 divided by lambda for the mesic atom. So compare with this, so it will be equal to, instead of r infinite, now we should see for the r infinite value. R infinite value is directly proportional to the mass, right? Now instead of R infinite, this we will take, which is equal to mass. Instead of R infinite, we will take R of mesic atom. So for the mesic atom, it will be mu. So what is this mu? Mu is nothing but 186 point mass of electron. So 186 point R infinite, can I write R mesic, which is equal to 186 into R infinite. Yes, so it will be R mesic. I can write it as 186 into R infinite into 3 by 4. Okay, so if you substitute the values, 1 divided by lambda m for the mesic atom, it will be 186 into R infinite is 1.097 into 10 to the power of 7 into 3 divided by 4, or if you reciprocal this, you will get the value for lambda m in terms of meter, and energy in terms of an electron volt, and the radius also is in term of electron volt. So every question, it is for the finite masses they are asking, and you need to be clear when to substitute the value for the reduced mass and when to substitute the value for the infinite mass. Okay, substitution should be way clear. Okay, Yes. Now let us proceed to the next question and the final question. We have in this question a muon form cosmic rays trapped by a proton to form a hydrogen like atom given mass of a muon to be equal to 200 mass of 200 times mass of an electron, the longest wavelength in the spectral line of Lyman series. Now here the point is longest wavelength. When will be the longest wavelength means when n which is equal to 1, n1 which is equal to or initial which is equal to 1 and n final which is equal to 2 means then only we will get the longest wavelength in spectral line of hydrogen series. Here muon uh, from cosmic ray trapped by a proton they are saying to form. So a muon and the proton that it comes again the reduced mass mu which is equal to mass of muon and the mass of proton divided by mass of muon plus mass of a proton, and again the mass of muon it is given 200 times of a mass of last time it was 207, here it is 200 times of mass of electron, and here it is mass of proton is 1836 times of mass of electron divided by 200 times of mass of electron plus 1836 times of mass of electron. If you solve this you will get the answer to be 180 times of mass of electron. Now the longest wavelength in the spectral line, the formula is again 1 divided by lambda which is equal to R infinite for the hydrogen atom, 1 divided by Ni square minus 1 divided by N final square. So after solving 1 divided by lambda h which is equal to R infinite into 3 divided by 4, right? Yes, in place of R infinite, last problem was also very similar to this problem. Yes, R infinite, it is depending on the mass. Now, R of muon will also, muon and proton, we will form a meso atom only. We will consider the meso atom only. It is a Rydberg constant for meso atom, which is directly proportional to the reduced mass. Instead of this reduced mass, we will substitute the value to be 180 times of mass of electron. Mass of electrons will again be R infinite. So 180 times of R infinite. So here it will be 1 divided by lambda p which is equal to um, lambda p or lambda mu you can write. Lambda mu which is equal to or lambda m, it is your wish, you can name anything if you want. Instead of R infinite it will be R mu. So R mu can be replaced by 180 times of R infinite into 3 by 4 or lambda mu which is equal to, if you reciprocal it will be 4 divided by 180 times of R infinite is 1.097 into 10 to the power of 7 into C in terms of meter. Okay, so you need to solve this and you need to keep answer in terms of meter. So this will be the final question. I hope this concept, that is Bohr model of hydrogen atom, is very clear to you people. For more videos you can visit my YouTube channel. Thank you for watching.